This video is going to show you how to solve systems of equations using substitution. So, like graphing, there are three different possible solutions. One solution, no solutions, and infinitely many solutions. One solution would mean that your equation solves just fine. No solution would be something like at the end you're getting something like 2 equals 7 different numbers, 18 equals -3, anything like that is going to be a no solution. Infinitely many solutions would be when you get something like this, 8 equals 8, 9 equals 9. It's the same number equals each other. So we're going to look at two different possibilities. The first one is when you already have one equation isolated for a variable. So what I'm looking for is I want this number, or one of the variables, to be completely isolated. Nothing is happening to it. It is completely by itself on one side of the equal sign. So in this case, this would be a yes. There is already one variable isolated. It is x. It is completely alone. So I don't have to do this detour here. So my second step is I'm going to take my variable that's isolated and I'm going to be plugging it into my other equation. I'm substituting it in. That's where this name comes from. So I'm going to rewrite this here. So I've got x equals y plus 1 and -2x plus 3y equals 2. So x is what is isolated here. That means that this stuff on the other side is going to be going into that x spot. I'm going to substitute that in, and then I'm going to solve the equation that I have left. So I'm going to be solving this equation for y. If in this step you do not have all of one variable, then that means that you have not substituted correctly. You should have all y's or all x's when you're solving. So I'm going to start by, I'm just solving this equation. So I just apply all of my rules for solving. So I'm going to start by distributing. So -2y, -2 times 1 is -2, and then nothing else is changing. I'm going to combine my like terms here, so this -2y and this 3y is going to give me 1y minus 2 equals 2. I'm going to add 2 to both sides to cancel that out. So I've got 1y equals 4, divide by 1, cancels that out, and I get y equals 4. Now I'm going to take that and substitute it back into one of the original equations. So I'm going to go with the one that's already isolated. So x equals y plus 1. I'm going to substitute that 4 in for the y and solve for x. This one's nice and easy. I'm just going to add 4 plus 1, and I get x equals 5. I am then going to check this. So right now I think that my solution is 5, 4. I'm going to go up to the other equation, so that -2x plus 3y equals 2. And I'm going to substitute the 5 and the 4 in for the x and the y, and we're going to check to make sure that it is in fact a solution. So I have so this is that case where I'm not sure if these things are equal yet. -2 times 5 is -10. 3 times 4 is 12. Is that equal to 2? Well, -10 plus 12 is 2. 2 equals 2. So 5, 4 is my solution. So that's the case where I have one of the equations is already isolated. Let's look at what happens when we don't have an isolated variable. So I do not have, these sixes don't count. I don't care about those sixes. I care about my y's and my x's here. My y's and my x's, there is nothing that is the same, or I'm sorry, it's nothing that is isolated, nothing that is on one side of the equal sign completely. So this is a no. That means that I'm going to have to solve one of these equations for the variable. So no, nothing, completely alone. So I'm just going to pick the first equation. Either one of these is going to be fine to solve for. So I'm going to go with this first one. And I'm going to solve it for y. So I'm going to subtract 6x from both sides. I get 2y equals negative 6x minus 6. Divide everything by 2. And I get y equals, so negative 6 divided by 2 is negative 3x, and negative 6 divided by 2 is negative 3. So now I have an equation that's isolated. I need to go back up into the other equation. So I cannot, for this step, use this equation. I have to use this next one. So I'm going to rewrite these. So y is isolated, so that's where I'm going to be plugging stuff in. This is going to go in to my y, and then I'm going to solve that equation that results. So again, I have only one type of variable at this point. That's what I want. That's what I'm doing when I'm substituting, is I'm getting all of one variable so that I can solve for it. Okay, so I'm going to start by distributing again. That's pretty much always what I'm going to do to start. So 2 times negative 3 is going to give me negative 6. 2 times negative 3 is going to give me negative 6. I'm going to combine my like terms here, my negative 4x and my negative minus 6x. I get negative 10x minus 6 equals negative 6. Add 6 to both sides. I'll shrink this down in a second. Negative 6 plus 6 is 0. Divide both sides. 0 divided by negative 10 is 0. All right, so x equals 0. I'm going to go back to one of the original equations. So it has to be the original one, not the one that I solved here. It can't be this one. So I'll just go back up to that 6x plus 2y equals negative 6. And I'm substituting 0 in for x and solving for y. So 6 times 0 is 0. Technically, I would subtract 0 from both sides. It's an unnecessary step here, but I'll just show you all of the steps. I get 2y equals negative 6. Divide both sides by 2. I get y equals negative 3. So right now, I believe that my solution is 0, negative 3. So we're going to check that in our other equation, which is that negative 4x plus 2y equals negative 6. All right, so I think that x is 0. I think that y is negative 3. Negative 4 times 0 is 0. 2 times negative 3 is negative 6. 0 minus 6, oops, 0 minus 6 is negative 6. Negative 6 is, in fact, negative 6. The solution checks out. So my solution is 0, negative 3. So those are all of the steps that you're going to use to solve a system of equations by substitution. The key is checking to see if you have an isolated variable first, and then it's just a matter of substituting and solving a couple of times.